So I'm going to show you how to create a T confidence interval for a single mean when you're given summary statistics rather than the data itself and you're working in Excel. Here's our example. A new diet plan claims that participants lose an average of 10 pounds in 30 days. Now that just sounds too good to be true, so you decide to test this claim. 20 of your friends, including yourself, try the plan for the 30 days. You find that the average weight loss for yourself and the 20 people is 8 pounds with a standard deviation of 1.5 pounds. And the distribution of your weight loss does look approximately bell-shaped. Let's create a 99% confidence interval to estimate the true average weight loss and disregard this claim by the company that it's 10 pounds for now. Let's just use the data we gathered to say where the data suggests the real average weight loss is. Let's extract the information from this story problem to get ready to put it together into a confidence interval. It's very important to label your values in Excel to keep yourself organized. So we'll be using the sample mean, which in this case was 8 pounds. Sample standard deviation, which was 1.5 pounds. Sample size, here, 20. We'll need the confidence level, which is related to the level of significance. And the level of significance is the complement of the confidence level. So a 99% confident has a 1% level of significance. Then we'll use these things to create a margin of error. Put the margin of error together with the sample mean to get our lower bound and our upper bound. All right. So to find the margin of error in Excel when given summary statistics, we'll use the confidence.t function. So equals, start typing it out, confidence.t. The alpha level is the complement of the level of significance. Alpha is the level of significance. Standard deviation, and our sample size. Great. The lower bound equals point estimate, sample mean, minus margin of error. Then the upper bound is the point estimate plus margin of error. So equals point estimate plus margin of error. Putting this all together, I am 99% confident that the average weight loss for this plan is between 7.0 pounds and 9.0 pounds. It's important when you interpret this confidence interval, it doesn't mean there's a 99% chance the average weight loss is between these two numbers. It means there's a 99% chance that the sample I took was a sample that will capture the true average weight loss when I create the confidence interval. The thing that has the uncertainty, the thing that's random, is the sample I took, not the true population average weight loss. That's a number that exists out in the ethers. But what's random each time I do it is the sample. Let's think a little more about the conditions needed to be able to use this method of analysis. The first and most important step is a random sample. Do you think a sample of you and your friends is a random sample or a haphazard sample? I would be highly suspicious that you and your friends represent all of everybody. So here we're a little uncertain that that first condition is met. After that, you would need a large enough sample. Our rule of thumb is n greater than or equal to 30. So this is a little bit small, but there's a second condition that can meet the required conditions, and that's a normality assumption, that the thing you're sampling comes from a bell-shaped curve. And here I mentioned some kind of further analysis to double check that the sample looked bell-shaped, and we did all right there. So we are fairly justified in using this method. Again, it would be better, it would be stronger evidence if we had a sample that was more randomized. Taking a look at this confidence interval, our data suggests that the real value is between 7 pounds and 9 pounds. What can you say about the claim the company made of 10 pounds? Based on this data we gathered, it doesn't seem reasonable that the true value for the average would be 10 pounds. Our data suggests it's between 7 and 9. Thanks for watching. Happy studies.